Okay, so quick recap on this, and I'm not going to give you time to copy it down if you didn't get it. There's a video, I can send that back out on these. But slopes, you need to have a general idea of when a slope is positive, negative, zero, and undefined. Visually, that should make sense. There is a formula. I'm not huge on the formula. Really, the only ones that really must know that formula are ones that are going on to the intermediate algebra, the trigonometry, the pre-calculus. We need that formula because things get a little crazy and the formula helps. But for you guys, you can plot the points, do a change in y over a change in x, count the spaces, and if the slope's positive, negative, that's a perfectly good way of approaching it. And if it makes sense, there's nothing wrong with understanding slope that way. Okay. Now, with that in mind, I'm going to keep trying to make these visual and have us see the change in y over the change in x. But I am going to also go through the formula because I don't know what direction you're going to go after this course. Okay. But the idea is I'm going to go over both. And ideally, the answer should be the same. So it doesn't make a difference. Okay. You find what works for you. You find what makes sense for you. So this was the example we looked at yesterday. We said, I believe that this was going to have a negative slope, and specifically, why? Because it's going what direction? From left to right, it's going down. That gives it a negative slope, okay? But when we checked, the change in y was negative 4, the change in x was positive 4. When we made that a fraction, it simplified to negative 1. It would not hurt my feelings if you made that negative 1 over 1. There's nothing wrong with that, okay? If I wanted to use the formula, a couple ways of doing it. You can do the formula logically. You can do the formula with the formula. I'll show you kind of both. Either way, it's still change in y over a change in x. Here's what I do. And I don't want most of you to do this because I think you might get a little lost. The change in y, do you see the 2 points written up here, the 2, 3, and the 6, negative 1? Right? What are the y values? The 3, the 3 and the, so that's basically our y1, that's our first y value, and our y2, our second y value, right? You could add, what's the change? If it went from 3 to negative 1, did it go up or down? Went down how much? To go from 3 to negative 1, how far did it go down? Isn't that change in y right there? That's a logical approach. I don't encourage that because that, even though that's what I do, it's easy to kind of get it mixed up in your mind. So if you're like, just give me the formula, okay, well we said take y2 minus y1, which would be, what's the y2? Negative 1 minus, what's y1? What's negative 1 minus 3? Isn't that the top of our fraction? How would I get the change in the x? I do it logically, and I want to keep making the sense out of what we're doing here, but the x values went from, looks like 2 to what? If it went from 2 to 6, how much did it change by? Isn't that number right there? If that's, you're doing too much, then don't do it that way. Do x2, which would be which one? What would be x2? What's our second x value? That's what that means by x2. It's the second of them. 6 minus x1. So 6 minus 2 is what? What is negative 4 divided by positive 4? Still. Did the slope change? That is an algebraic approach. I encourage you to start with the visual approach. The problem with the visual is I will have people miscount steps. That's not a horrible mistake because I would encourage what you do to make sense. In fact, I think in my first video, a lot of us, the way I drew this arrow, thought it went down 5 when it only had gone down 4 because my arrow was a little off. So be careful. If you do it visually, you might miscount steps. You're opening yourself up to that. If you do it algebraically, a lot of people will mess up with these integers and end up with a sign that's off. Or if they change the order on these things, it could change the entire answer, okay? What I would encourage you to do if you do it algebraically is to still stop at the end and go, does my answer make sense? Here's what I mean. We found that the slope is negative. Does this graph look like it has a negative slope? We said yes, because it's going what? Keep that in mind, okay? It always, and I always review this. We review this in intermediate algebra, and I will have people that will graph a line going down like this and tell me the slope is +1. I go, that should stop you. Your brain should look at that and go, that slope's not positive. See what I'm saying? So don't use the formula to disconnect from what we're doing, but be careful if you want to use the visual. There are other potential mistakes. Let's keep going. And I'm going to keep visualizing these. So if you're wanting to do these visually, I think that's a perfectly good approach. That gets a little less practical when the numbers get crazy big. You probably won't be seeing much of that in this course. That's more that we see in the later intermediate algebra, the pre-calculus. We deal with crazy numbers. The formula comes in handy. Okay? Can you plot the point -1, -4? That's what we started with yesterday, right? Go 1 to the and down. Plot that point. Can you go 1, -1? 1 to the and down. So if I wanted the slope between these 2 points, could you count the rise over the run? Could you count the change in y over the change in x? What is the rise? How far up do I go between these? I heard plus. 3 up or 3 down? That makes that's a positive change in y. You with me? What's my change in x at that point? 2 to the right. Is that a positive or negative change in x? So what people will do is they'll then tell me the slope is 2 over 3. Why is that wrong? Why is the slope not 2 over 3? It's the rise, the y's over the, so it's the rise over the run, or the 3 over the. Would that answer change if I had started at this point and gone backwards? Just thinking here. Instead of the change in y being positive, it would now be what? And then going back, now the change of x would also be what? Is -3 over -2 the same thing as +3 over 2? They are actually the same, and here's why. A negative divided by a negative is a what? So this would still be -3 over -2. Let me be clear, the computer will mark you wrong. We don't leave it that way. But a negative divided by a negative is what? It's still a positive slope, isn't it? So either direction you go, you should get a positive slope. How else do I know it's a positive slope visually? Going uphill. So there should be some sense behind that, right? He's like, all right, I'm not loving this. What's the formula? Okay, y2 minus y1. What's my y2? Which negative one? The one on the y. You're pointing at it. Okay. So that's the y2 minus the. Now this is where you have to be careful. If you like this, it's not a problem. But you have -1, not -4. It's minus -4. We've dealt with that before. Over, what's x2? Minus, what is 1 minus -1? See the issues here? And you can do that in your calculator. It's not a problem. We should remember that we kind of had this a second ago. A negative times a negative makes it what? So that makes this a +4. That makes this a what? So really we're left with, what's -1 plus 4? Over what's 1 plus 1? Did the answer change? Which way's right? Which way's better is up to you, isn't it? Okay? The only time we really need this formula is when numbers get all crazy big. Otherwise, you could plot the points and count the jumps. Be careful that you don't miscount the jumps. Okay? If you like the formula, use it. You should get the same answer either way. Find what makes sense to you. Does that make sense? Can I keep going? I'm going to start with the formula this time. Negative 5, 4, and 2, 4. What is the y2 minus y1? I heard 4 minus. The most common mistake people do on this, not the most, but a common mistake people do, is they'll do 4 minus 2. They'll like try to take these two from the point. That needs to stop. Because this right here is not the change between those two numbers. It's the change in y, right? The change in the y's. That's why we subtract the y's over the change in the x's. So we subtract the x's. So we subtract what? Or 2 minus, bless you. All right, that needs to stop now. Okay. What is 4 minus 4? What is 2 minus negative 5? Yeah, 2 plus 5 is? What is 0 divided by 7? And I like that some of you are a little anxious. You're like, uh-oh, this is either the 0 or it's the undefined. It's good that you remember that 0 has a rule when we're dealing with dividing, right? Can you put that in your calculator? Some of you are checking right now. Can you do 0 divided by 7? Put it in there. It works, doesn't it? What does it give you? If you're not sure, make better note cards or plot the point, right? Could you plot negative 5, 4? Could you? No, nobody can. Can you plot negative 5, 4? Can you plot 2, 4? Can you visually tell me whether that slope looks like it's 0 or undefined? See what I'm saying? So the picture is a way of reinforcing. The change in y is nothing. It doesn't change up and down, does it? Does that make sense? This is a flat line. This is a nice walk, right? What happens on the next one? What's my y2 minus y1? What's my y2? Basically the second y value minus. What is negative 4 minus 2? Over, what is x2? Minus, what's 6 minus 6? What is negative 6 divided by 0? The calculator freaked out, didn't it? You can't pull out groups of nothing. We've talked about this. This would be like the 5th time. That's okay. If you're not sure, could you plot the points 6, 2 and 6, negative 4? And you tell me what that line looks like? Because somebody was about to tell me that's a slope of 0. Does that look like a flat slope of 0? No, that's a what? Yeah, that's a call an exorcist, remember? Nobody's walking up the wall like that. No Spidey Man. None of that. Like, that's not cool. Okay? You got bit by a radioactive bug. Good for you. We're not going to define that. Is that all right? Any questions on that? Okay? Visually, that should be a, oh, wait, that's not 0. That's undefined. You need to know that word, though. This is not your answer. Your answer will be that the slope is undefined. All right. Any questions on this before we continue? Okay. And we need to be able to put all this together. And I think we're almost ready to do that. A couple more terms that we're going to be using. I'll use this more. We will need to finish up some notes. I'll probably do it at the beginning of next week. We have an assignment that's due at the beginning of the week. And then I'll kind of ease into the last of the notes. And we have one more assignment. And our quiz is going to be 2 weeks. Okay? It's all on the calendar. I'm not trying to surprise anyone here. What does it mean if I say lines are parallel? So that's a really good geometry answer. Unfortunately, this isn't a geometry class, right? But that's what it means. Two lines that are parallel means they never are going to, right? They never cross, they never intersect, right? What does that mean? This is a really good geometry answer. And it is true. But what does it mean algebraically if two lines are parallel? That's this side. And this is what you need to learn. Algebraically, if they never cross, they never get any closer, they never get any further apart, right? That means they have the same rise, they have the same, and if they have the same rise and run, they have the same. Does that make sense? If I ever tell you two lines are parallel, yes, that means they don't cross. Unfortunately, that won't help you much in this class. You need to know that means they are the same slope. Does that make sense? I'm not as big on the different Y-intercept. If they have the same Y-intercept, they'd be the same line. So that's why we technically have that. But for you guys, pretty much if I say parallel, I'm expecting you to use the same slope. Is that fair? Okay, that's the easy one. The next one's a little more complicated. Can I scoot this down, or do you need a second to color? All right. In geometry, we also learn about perpendicular lines. They're very useful. There's a lot of things we can do with perpendicular lines. But that's where they do cross, right? Specifically at a what? A nice 90-degree right, we call it right angle. So think where they cross, basically think of it like a corner of a paper. They cross at that 90-degree angle, a corner of a book. They cross at that 90-degree angle, right? Does that mean they have the same slope? They can't if they're going to cross, right? So this is our geometry answer, which is useful. We will use it in like a trade pre-calc. We use that a little more. But this is the algebraic answer you need to learn. That to get two slopes that are perpendicular, that means that if the first one's positive, the other one must be, that's what I mean by opposite. Does that make sense what I'm saying? If one is positive, A over B, the other one must be negative A over B. It must be going down. If one goes up, the other goes down. Does that make sense so far? But that's not enough. Opposite slopes don't make them parallel. And so what I did is I actually chose two numbers here. I drew some that cross at this nice 90-degree angle. But this one goes up 2 and over 1. Up 2 and over 1. If I want to go to another point, up 2 and over 1. Are you seeing that slope? To get to another point, up 2 and over. This one right here, or Y1, has a slope of 2 over 1. Agreed? This sucker right here is perpendicular because I drew it to be perpendicular. Okay? Its slope is not 2 over 1. It is not up. It is down 1 over, down 1 over, down 1 over. So not only is it opposite, but the 2 over 1 flips. The word for that is reciprocal. So it cannot just be opposite. It has to be both opposite and reciprocal. Does that make sense? For it to form that 90-degree angle, I'll give you the way I have it down here. Think of it this way. If the first one is A over B, then the second one must be negative, flip it, B over A. Opposite and reciprocal. If the first one's A over B, the symbol right here says it will be perpendicular, a little 90-degree angle there. If the second one is negative, B over A. What? This will be the last time I make a table. Not because there's anything wrong with it or, oh yeah, we don't make tables. That's like what they do with their little kids. It's not like that at all because I already told you, we need that skill in advanced math. Whenever I get to a graph that I don't know, I make a table and I figure out what the graph looks like. That skill is more important than you know, okay? But for graphing a line, it's almost like crutches, right? You're like, what's this guy got against crutches, right? Crutches are a great thing. You hurt yourself, you need crutches to get around, correct? Does that mean you want to be on crutches the rest of your life? That doesn't, you don't get around quickly that way. It's not practical, is it? They're a tool that helps you understand, that helps you build to the point that you can now walk normally, move along quickly, right? So this is a crutch. It's a good tool that we need to know anyway, but you should not be taking crutches for the rest of your life. Fair enough? Okay. I encouraged you that there are 3 numbers that you can check here. If it's not a fraction, it was just -1, 0, and 1. Those are not the numbers, so don't write those down. Because I said if it is a fraction, then I want to clear out that denominator, right? So a 1 won't do that. What might do that? A -3, a 0, and a +3. That'll clear it out. By the way, if that's really complicated to you, that's okay. You won't have to do all this when you don't make a table anymore. You use a shortcut, you won't have to do this anymore. And you can graph it quick and accurate. Okay? Let's start by plugging in a -3. What is -2/3 times -3? Just this first part. What is -2/3 times -3? Yeah, what is 6 divided by 3? Notice the 2 negatives make that 2 positive. And what's 2 minus 1? Good. When x is -3, y is 1. That is a point, isn't it? So far, so good? Our next point's a little easier. If I plug in a 0, y is equal to, what is -2/3 times 0? So all I'm left with is, that was nice. We have a second point. And last, now the 2 is, so -2 minus 1, y equals, can you plot those 3 points? Then you can graph a line. But doing that process took us 3 minutes, right? I don't know, I should have looked at my time. 2-3 minutes. If there were only a faster way. There is, right? It's called y equals mx plus b. And what I do is I say, remember we discussed this in the last section, that what? How many points do I need for a line? And 1 is already in this equation right here. I already know 1 point in there. What point is that? The y-intercept, which is the b. When I ask you to graph using y equals mx plus b, that b is a point. Start at the y-intercept. When x equals 0, we get the point, basically, see if I can move this over a little bit. When x is 0, we get the point 0, b. What number is up there where the b is? A -1, isn't it? That means I know from the start the point 0, -1. Did I need to plug in the 0 to know that? Could I plug in the 0 to find that out? But that b will always be the y-intercept. That's convenient, isn't it? Because I only need 2 points, and guess what? We've got 0, -1. Plot that point. How do I get my second point? That's step 2. We will use the slope to graph more points. What is the slope? The slope is the m, is the rise over run, is the change in y over change in x. You understand slopes. We now understand that basically the slope is built into the equation, and we can already see it. What number is up there where the m is? What number's up where the m is? See, it's mx plus b. What number's up there with the m, or with the x? That negative 2/3. That's the m. That's the slope, isn't it? I'm going to use that, and from the y-intercept, I will go to, what does it mean to rise negative 2? Well, yeah, what does it mean to have a change in y that's negative? We will go 2 and 3 to the 2 down, and 1, 2, 3 to the right. Do you see that point that we just created using the slope? What is the point that we just found? Was that in our table? We literally don't have to make the table and then graph the points. What we can do is using y equals mx plus b, I can build the table right onto the graph. In fact, if I wanted another point, I would go down another what? Go down another 2 and over another. Does that still form a straight line? And that point would now be, instead of negative 3, negative 4, negative 5. And down 1, 2, 3. Oh, did I mess that up? I did. X goes first. Shame on me. Sorry about that. Somebody is screaming at their screen right now. That would be 6 comma negative 5. Somebody's like, well, we also had negative 3, 1. How could we get that point? Okay, using the slope, I know that if I go down and right, that would be the same thing as going up and left. This is more advanced. So if this freaks you out, don't worry about this, okay? But going down and right, going negative 2 over 3, is the same thing as positive 2 over negative 3. They're still both a negative slope. So I could go up 2 and back 1, 2, 3, and notice, nope, get all excited and start throwing the points wherever I want to. But notice what point we just found. Negative 3 comma. Do you see how we can build the graph, we can build the table directly into the graph. I just found 4 points. Did I have to do any of this complicated arithmetic to do that? You do what? You start at the y-intercept, and you too use the slope to find more points. How do I graph the line from these points? Connect the dots. And on your homework and on the quizzes, you only need 2. I recommend 3 when you're doing it by hand, and you will on the activity. Okay? But the idea is 2 points make a line. So you do that on your homework, plot the 2 points, hit submit, and we're done. Okay? All right. So we know the y-intercept, and like I said, it's called slope-intercept form. The only critique I have is I wish they'd call it slope y-intercept form, because that's the most common mistake when people are doing this. There's a couple common mistakes, but the most common mistake is that people will take that b and they'll put it on the x-axis. That is not the x-intercept. That is the y-intercept. Specifically, we said the y-intercept where x equals what? And so the point that we get from that is 0b. That is the first thing we get from y equals mx plus b. You with me so far? How many points do we need for a line? How many do we have? That's a point right there, isn't it? How do I get my second point? We use the rise over the run, the change in y over the change in x, and I build more points from the y-intercept. I literally build the table right on the graph. Does that make sense? Can I scoot this down? Do you need the very, very top part? Okay. I'll give it about another 20 seconds, and it's going to go away. Okay. That's not enough time. Take a picture. It'll last longer. Just messing with you. Sheesh. It's okay. I promise you 10 more seconds. I'll chill out. First thing you need to be able to do is identify the slope, the y-intercept, and from that graph it. So let's take the first equation, 4x plus 1. What is the y-intercept? And then if you do this, I will not be happy. Some of the homework will let you do this. They'll say, what's the y-intercept? And you say 1. And they'll go, good job. That bothers me because the y-intercept is a point, not a number. That means it should have an x and a y. Okay? So what is the y-intercept? What's the x value? What's the y value? And that's going to help you because people are less likely to put that on the x-axis because it's not the x-intercept, right? They'll go 1 and just stick it on the x-axis. No, no, no. 0, 1. Where is 0, 1? 0 and up. There you go. Second, use that slope. What does that mean? Well, what is the slope? That's the m, right? Now be careful, and this is a weird thing for people. Somebody's like a slope of 4. So rise 4, run, there's no number there. This is the only time I can think of in mathematics where like, oh, if that were only a fraction, my life would be easier. Because slopes are rise over run. I want a numerator and a denominator, so give it a denominator. 4 is the same thing as 4 over 1. And what does that do for me? It lets me find the next point. Don't go to the point 4, 1. Don't go to the point 1, 4. From the y-intercept, go up 4 and over and plot a point. What if I wanted another point? I'd go up another and over another. You don't need that many points, but that you could do more, couldn't you? What if you want to go backwards? Where's my advanced students at? How would you go backwards?
Go down 4 left.
1, 2, 3, 4, and left 1. Does that still fall on our line? It sure does. Negative and negative is still a positive slope. Could you draw a line from that? Literally, it's connect the dots, right? If you turn in your paper and that's what it looks like, I will penalize you. Because the line is not only restricted there, it goes on forever. So what do I put? Make sure you put the arrows on the ends. Next one. First, what is the y-intercept? -8 is not a y-intercept. And that's from the b right there, right? The b, mx plus b. The b is the y-intercept. Can you plot the point 0, -8? Freaking A, 7, 8. Okay. From there, our slope is what? Last time it was 4 because it was 4x. This time there's no number with the x. You have to know if there's no number that it's a -1. There's a 1 there, right? That's still not a fraction. Make it a fraction by making it -1 over. Now this is one I did this on purpose because if I want to use the slope, then I put my pencil all the way down to the y-intercept. And to get to the next point, I go what? Down one end. And connect the dots and you're done with your line. But that gets a little weird, like as we keep going down and right, it's kind of off the graph, right? So that might be one where we want to go backwards. So instead of going down 1 and right 1, we could go what? Up and left. See how that works? And I could do way more if I really wanted to. See the up, left, up, make sure I did that right, up, left. And I could just keep building more points kind of in that region that's where we see it, okay? You don't have to work backwards, but here's what you just said. -1 over 1 is the same thing as 1 over -1. I agree. Both of those, if I divide them, are -1. They're the same number, just one's going right and down, the other one's going up and left. Okay? Was that faster than making a table? I think so. In fact, we just found 4 points like that. I just found 0, -8, 1, -9, -1, -7, -2, -6. That was quick. That's way quicker than having to plug it in algebraically, right? Let me be clear. If you get to the test and you're like, I'm messing up with mx plus b, then make a table, fill it in, and graph those points. You'll graph a line. There's nothing wrong with that. Okay? If you're in my intermediate algebra class doing that, we got a problem. But this is the class that if that's how you graph, then guess what? You can graph. Do it that way. Fair enough? Let's keep going. Y equals negative 2/3 x. mx plus b. That's weird because there's only one number this time, right? Is that negative 2/3 my m or my b? I'll give you a hint if you're not sure. It's mx plus b, correct? The m is the one that's with the... So the m is what? What's the b? There's no number there, right? Does that mean it's a 1? That's not how it works this time. That's with a variable in the front, right? If there's no number at the end, it's like there's a... You with me? So what is our y-intercept then? Thank you for not just saying 0. It's 0, 0. Oh, AA run. All right. Start at the y-intercept of what? And from there, I heard go down 2 and over 1, 2, 3. What if I wanted another point? Go down 2 more and what if I wanted to go backwards? Take 60 seconds, check with your neighbor. How are we doing? How are we doing on this? I need you to know how to graph these. Can you do that? Not life. How are you doing with this? We can't fix your emotional problems. They don't pay me enough for that.
But when you become a doctor, they still can't pay you enough to do.
I'm just joking. I don't. Are we doing okay? Here's generally what happens, just so you know. Not to take up your 60 seconds. Most of you look like you're pretty much done talking. I'll do this. I think I'm pretty good at covering this. And out of a class of 30 people, 20 of them have no problem. They're like, this makes sense. I wish I'd been taught like this at the beginning. It opted out. Or they were strong with it already and not putting all of it on me. But if you get 20 people that like knock this out of the park, awesome. You're like, so what about the other 10? They get it. It just takes them a little longer. And that's why I encourage you guys to work together. I'm going to give you an activity. That activity is going to be due at the beginning of next week. If you're struggling with that, find somebody else in the class that gets it and have them help you. Okay? By the end of it, you should be able to do these quickly and accurately. This is a large part of the next test. This is a skill that you should not lack going into any course past this. You need to know how to graph a linear equation. Okay? This is not a negotiable. This is not a geometry thing that you're not going to see ever again. This is not negotiable. You need to know how to graph y equals mx plus b. Okay? All right. What if? Don't get mad. This is what your worksheet's going to look like anyway, so I'm actually prepping you for it. What if? This is standard form again. This is ax plus by equals c, right? That's not cool. We just got used to mx plus b, and then they give me a question that's not an mx plus b. What do you do? Besides swear at me under your breath. Right? Could you get it back into y equals mx plus b? This was a skill that was in your last quiz. Basically, solving for a variable with just a bunch of letters. This is what they were prepping you for. Okay? If I can get that y by itself, then the equation will be in y equals mx plus b. This is an inverse operations thing. How do you solve for y? How do you get that y by itself? It's being multiplied, so we will divide, and it's being added, so we will, which will we do first? PEMDAS backwards. We will subtract 3, 3, and that's a really big deal, because on the right side, 8 minus 3x is not 5 of anything. Do not combine those, right? They're not like, would you put the 8 minus 3x or the negative 3x plus 8? You're like, why does it matter? Well, look at what our goal is, mx plus b. Where do we want the x? So let's keep that x at the beginning. Negative 3x, and the 8 is still positive. Does that make sense? Now, what are we left with on the left side? Now, how do I undo that multiplying? Both sides by what? I, for years, have done this where I just divide the entirety of the other side by negative 4, and I know that negative 4 distributes, and I've had no problem with that. If you know that, you're good. I've found more success with my students when I just say if we're dividing one side by 4, do it on the other, and it basically do it across each term. So if that helps you do it, if you're like, I didn't need that, then don't do it. I don't, but I found more success with students when they start distributing the division. Okay? What's left on the left side? On the right side, what is a negative divided by a negative? What is 8 divided by negative 4? See, that negative 4 had to divide to both of them. Did I simplify the 3 over 4? Do you want that to be 0.75? Is that a useful slope? Heck no. Leave it as a fraction so we have a rise over run. Does that make sense? Okay, this is the big element, so don't freak out. This is kind of finishing it up. Could you graph from that? What's your first step? 0b, I heard 0, negative 2. And from there, what's the m? Which means the 3 is positive, so I'll go 3. The 4 is positive, means 4 to the. So from that, from the y-intercept, not from the origin, that's another thing some people do, don't do that. From the y-intercept, we go up 3, we go over, we plot a point. And how many points do I need? I got 2. Draw your line. Can we keep going? Is the next one ready to graph? I had some people, I think it was in my other class, that were going through and just always graphing using x and y intercepts. This next one will destroy you. You will not be happy with this. Because this will have this will have a y-intercept of negative 1. You're like, what's the problem? That's easy. It'll have an x-intercept of 3/2 or 1.5. You're not going to be able to plot that accurately. You're not going to be able to do that in your technology. Your method just broke. It's a good method when the y-intercepts and x-intercepts are nice, right? But if it was an x-intercept of like 17/3, you're out of the water. Okay? What do I do? Well, let's put it in y equals mx plus b. How would you do that? Talk me through it. Add the what? If I do it to one side, what is left on the left side? 3y equals. On the right side? Minus. Don't combine those, put the x first. Is that y equals mx plus b at? What do I need to do next? What gets divided by 3? Each term, distribute the division so that y equals what? Could you graph that? Starting with what? Start at 0, -1. And from there? 2 to what direction? The rise is not right or left. The rise is 2 up and 3 to the, so 2 up, 3 to the right. There's our second point. Questions, concerns? That is what your first activity looks like. You'll take the equations, put them in y = mx + b form. You will then graph the y-intercepts and use the slopes to get to the next point. Does that make sense? That's the big thing I need you to know by the end of this week, because we're going to be building on it. I want to start with the next section where we're writing equations. And I'm expecting to need a little more work on this next week. Okay, so don't freak out about that. But I want to get this done and give you guys time to start the activity today, at least see it. Okay. So this is basically on writing equations, and they start off really easy. And I've seen questions like this. In fact, I'm going to move this. All right. They gave me a point, and they gave me a slope. And they say, if you know the point, 0, 3, and you know the slope, you know the point 0, 3, and you know the slope is 3, what is the equation? The only way this is an easy one is if that 0, 3 happens to be the y-intercept, because that's our formula here. mx + b requires the slope. Well, guess what? We've got the slope. But it requires the b, which is the y-intercept, right? Did they give me the y-intercept? If you plotted the point 0, 3, would it be on the y-axis? Then guess what? That 3 is the... And so if they do that, your life just got easy. The equation is what? Y equals... Here's the bad news. I moved that other example down. Not to be mean. I moved the next example down basically because the next one, that point that they give me, isn't the y-intercept, is it? So we're all in trouble now. Nope. There's another way. And it's called the point-slope formula. And it's already right there. So if you want to start copying it down when we talk through it, that's fine. But the point-slope formula is kind of like the slope-intercept formula. The slope-intercept formula has two things, a slope and a... The slope-intercept formula has two things. It has a slope and a... It's called the slope-intercept form because it has a slope and a intercept. That's why they call it slope-intercept, right? They're not trying to trick you here. This is called point-slope because it contains two things. It contains a... which is right here. And it contains a... no, just slope. It has a point and a slope. Does that make sense? Okay. Where did this formula come from? I'm going to take 2 minutes and show you. Okay? It's not a new formula. You're like, that doesn't look like anything I've seen before. That's terrifying. Okay? You don't have to memorize it. As you use it a lot, you get used to it and memorize it. You don't have to memorize it. Put it on a note card. Doesn't hurt my feelings. But we should understand where it came from. Let's start with this. Do you see the equation for slope? M equals. Does that formula make sense? M is change in the y's over change in the x's. Does that formula make sense? Anyone worried about that formula? Slope, we started with the beginning of our notes, change in the y's over change in the x's. Agreed? What if I wanted to take that equation and I wanted to clear out the fraction? Could you do that? That's a terrifying fraction, but could you multiply by the denominator and clear it out? What would you multiply both sides by? What's the denominator? x2 minus. Would that clear out that denominator? Yeah. Poof, poof, group with a group. I can't just do that. I can do anything as long as what we do to one side. You with me? Now, I'm going to reorder this. I'm not going to distribute this. That's not the purpose. But I'm going to put the m at the beginning. x2 minus x1 is equal to y2 minus y1. Here's the difference. When I use point slope formula, I'm not going to use 2 points. I'm only going to use what? 1 point. Means I don't need this 2 anymore because I'm not using 2 points. I'm only using 1. What equation did we just create? Y minus y1 is equal to m times. Is that a brand new formula? It's literally just the slope formula multiplied up. Does that make sense? Doesn't make it look any less intimidating, but that's what it is. Okay? So that was extra just because I like you. What are we going to do with it? I'll show you. I'm going to go up to this example up here. Do you see the 0, 3? Can we all agree that 0, 3 is a point? So here's what I'm going to do. I'm going to plug the 0 in for the x1. I'm going to plug the 3 in for the y1. I'm going to plug it in for the point, for the yellow part of this equation. Does that make sense? So it becomes y minus, what's the y value there, please? Equals, do we know the m? Somebody go, yeah, they gave us the m. Nobody? You guys aren't participating on it. That's fine. What m did they give us?
3.
So guess what we can plug in right there? X minus, what's the x value? If we distribute this, I'm left with my y minus 3 is equal to 3x. If you want to put plus 0 or minus 0, you can, but we're just left with 3x. Could you solve for y? How would you get that y by itself? And y is equal to? Did the answer change? Now let me be clear. If they give me the slope and the y-intercept, it's way easier just to plug it in. Agreed? But on our next example, they're not going to give me the slope and the y-intercept. So I need a new process. And that's called the point slope formula. Does that make sense? All right, let's do one more example then. Step 1. I cannot use the slope-intercept formula. Though I have the slope is 2, 5, a y-intercept. If I go graph 2, 5, is that the y-intercept? That didn't work, did it? So what do? We use what's called the point slope formula because they gave me a point and a. If they give me a point in the slope, use the point slope formula. I'm not trying to trick you here, right? What is the point slope formula? Y minus, what's y1? Y minus 5. You fill it in. Equals, what's m? Times x minus. That is step 1. I just said fill in the point slope formula. Did you just do that? Some questions you're done. They'll say, what's the answer in point slope form? You write that in, you're done. I most often will tell you to turn that back into slope-intercept formula. And if I do, that means solve for y. If I do, that means first, you will distribute, take the 4n. So now we have y minus 5 is equal to? Last, solve for y. We get y equals That's going to get you through probably about 80% of your homework at this point. Does that make sense? This is not on your activity yet, but I would encourage you to start getting ahead on this, because this, if this is easy now, awesome. Work through it. It's going to be easy. If this is intimidating right now, please work through it, because I'm going to build on this when we get back next week. It doesn't get much harder, but it gets a little harder. That makes sense?